Okay, good morning class, right? Okay, so we go to our discussion, continue to our discussion. Alright, so Bernoulli Principle, right? So what is state the Bernoulli Principle? So the Bernoulli Principle state that the pressure of moving liquid decreases as the speed of fluid increases and vice versa. So means when the velocity is high, the pressure is low. Okay. So let's see this example. Okay. So let's say here the water flows, right? So when the water flows, right? So here, okay, so the velocity should be lower here at this part. Okay. So when the velocity is lower, the pressure should be higher. Okay. So that's what's the Bernoulli state. So the pressure higher means the water can rise higher. So let's say at this level. Okay, so at here, okay, you can see because the tube become narrow here, so the velocity is higher, right? So the pressure will become lower. Okay, so the water can only rise until here because of the pressure is lower, so the water cannot rise higher. Okay, and then this one because it just come up from the high velocity. Okay, high velocity. So this one, the velocity is lower. Okay, sorry, the velocity is higher. Okay, compared to this one. Okay, compared to this one. So compared to this one is higher. Okay, so the pressure here is higher also. Okay, but it's like in the middle. Sorry, in the middle here. Okay, between those three. Okay. So I repeat, okay, I repeat. Wait. Hmm. Hmm. Okay, so I repeat this one, the velocity is lower. Okay, so pressure is higher. So pressure can push the water. Okay, it can rise up higher. So this one, the velocity is higher. Okay, because the tube is narrow here. So the pressure is low. Okay, so means the water can only rise up until here. Okay, for this one, because the water just come up from the higher place. Okay, so this one the velocity is much higher than this one. Okay, from R is higher than P. Okay, so it is in between. Okay, between those two here. Okay, so this is the water level. Okay, for this one, okay, so for this one, the pressure, the velocity here is higher. Okay, so the pressure is lower. Okay, so the pressure, the water only can rise up until here. Okay, and this one, the velocity is lower. Okay, the velocity is lower, so the pressure is higher. So this one is the highest one. Okay, and this one, okay, so this one should be in between. Okay, between those two. Okay, P and Q. Alright, for this one, okay, so this one the velocity is lower, so pressure is higher. Okay, so the water cannot rise up. Okay, because the air will push the water go down because here the pressure is higher, right? So it will push the water down. So this one should be the lowest one. Okay, and then the velocity here is higher, the pressure is lower. Okay, so pressure is lower, so the water can rise up. Okay, so this one is the highest. Okay, so this one will be in the middle between P and Q. Okay, so that's how you answer for number 2, 3, and 5. So let's go to the next question. Alright, so diagram 8. Okay, diagram 8 shows two identical bricks X and Y placed in two different ways on a sandy ground were pressed by an identical force F. So what is the factor that causes brick Y to sink more into the sand? So the answer should be pressure, B. Okay, so number 12 is B. Alright, next one. Okay, diagram 9 shows 4 identical containers, okay, are filled with same amount of liquid, okay, but different in density. Okay, so which container exerts the highest pressure at the bottom? So this one you have to use the formula P is equals to H rho G. Okay, so H is the depth of the liquid. So this one have to change to meter first. Okay, because this one the unit is in meter for the density. So this one you have to change first. So I show you the first example. Okay, I showed you an example for P. Okay, so P the depth is 50 cm. So you change to meter 0.5. Okay, and then the density here is 800. Okay, and then multiply by 10. Okay, so you calculate. Okay, you calculate for P. So you got the answer is 4,000. Okay, so you got the answer here is 4,000. Right, then you calculate one by one, and then you will find which one is the highest. Okay, so the highest should be A. A, P. Okay, the highest one should be A. Alright, next one. Okay, for next one. Okay, so diagram 10 shows a hydraulic system which is in equilibrium. So when the piston A is pushed in, the piston B will be lifted up. Okay, so which of the following statement is true? So actually this one is a Pascal principle, right? So the Pascal said the pressure is transmitted equally or uniformly, okay, throughout the liquid, right? Throughout the liquid. Okay, so for this one, it says the pressure. So mean for Pascal, the pressure must be same, okay, for both pistons. So A and B. So the answer should be C. Okay, alright, next one. Alright, diagram 11 shows the weight of the plasticine measured in air and then in water. So the volume of water displaced is 2.5 times 10 power of negative 4. So what is the reading of X? Okay, so the already give you the volume here. So what you have to find is you have to find the buoyant force first. Okay, so the buoyant force, first one you have to know the equation. Okay, what is the connection between the weight, okay, weight of the object in the air, right, apparent weight, and also the buoyant force. Okay, so the equation will be, okay, weight, okay, weight of object, okay, in air is equals to buoyant force, okay, buoyant force, okay, plus with the apparent weight here. Okay, so this is the equation. So you already know the weight of an object is actually 10, right? Okay, but we don't know the buoyant force, right? We don't know the apparent weight. So what is actually the X? So X is actually the apparent weight here. Okay, and buoyant force you can find by using the formula rho V G. Okay, so the density is 1000. Okay, V is 2.5 times 10 power of negative 4. Okay, and G is 10. Okay, so if you multiply, you got 2.5 Newton. Okay, 2.5 Newton. Okay, so that is the buoyant force. Okay, so plus the apparent weight you need to find. Okay, so you got apparent weight is 10 minus 2.5. So you got 7.5. So that's the answer. Okay, so this is the equation here, right? Okay, so let's go to the next question. Okay, diagram 12 shows a fast flowing water in the filter funnel. Okay, so a ping pong ball is placed between the filter funnel and does not fall. PQR are positioned around the ping pong ball. So which of the following statement is correct? So pressure at P is higher than pressure at R. So if the pressure at P is higher than pressure at R, of course the ping pong ball will fall down. Okay. So A is wrong. Water flows at lower speed at Q. Okay. Water flows at the lower speed at Q. So this one is wrong. This one should be the highest speed. Okay. Higher speed. Okay. And then for C, pressure Q is lower than pressure R. Okay. Pressure Q is lower than pressure R. Q is lower than pressure R. Okay, so the answer should be C. Okay, 16 is C. Okay, next question. Okay, so diagram 11 shows a suction cup with a hanger. Okay, so what is the purpose of placing the suction cup onto the mirror? Okay, so this one is actually to decrease the air pressure inside the cup. Okay, so this one inside of the cup there will be a partial vacuum after the air come out from inside of the cup. So this one should be partial vacuum. So the pressure inside the cup is now lower and the atmospheric pressure is higher. So you push the suction cup here. So we stick at the hanger here. Okay. Alright, so this one, the answer number 11 is B boy. Okay, to decrease the air pressure inside the cup. Okay, right. The next one, so this one is actually a Pascal. Okay, so use the formula F1 over A1 is equals to F2. F1 over A1 is equals to F2 over A2. Okay, so already said calculate the value F if the mass of load is 30 kg. So here is 30 kg. Okay, and the cross sectional of area piston 1 is 90. Okay, so this one is 90, this one is 6. Okay, so F1. Okay, so F1 here, let's say we take the load here. Okay, so load is changed to Newton first, so 300. Okay, divide by 90. Okay, equals to F2 divided by 6. Okay, so you multiply, cross multiply, you got F2 is equals to 20. So the answer is B boy. Okay, the answer is B boy. Alright, let's go to the next one. Okay. Alright, so this one is actually the Archimedes. Okay, so diagram 14, okay, shows a hot air balloon moving towards the ground. So it moves towards the ground, it moves downward like this. So which of the statement describe the situation? Okay, so you know there are two forces that acting on the hot air balloon here. Okay, so the first one is actually the weight. Okay, remember if you want to label the weight must be at the center of the object. Okay, and another one is from the buoyant force. Okay, right. So if said that it moved toward, so means the weight is much bigger than the buoyant force. Okay, the weight is much bigger than the buoyant force. So the answer should be B. Right, the buoyant force of the hot air balloon is lower than the weight of the balloon. Okay, so number 14 is B boy. Okay, so let's say if move upward means the buoyant force is same as if the buoyant force is higher than weight. Let's say it's floating stationary. Okay, so means the buoyant force is equals to weight. Okay, right. Next one. Right, so this is Archimedes. So diagram 515.1 shows a metal hanging from a spring balance. Okay, so diagram 15.2 shows the metal block immersed in a eureka can fill with water. Okay, so what is the mass of the water in the beaker? Right, so you can see here. Okay, it become from 8 become to 6 Newton. Right, so from 8 to 6 Newton. So you can see the object here is totally immersed in the to weight, right? So means the weight of the object is actually equals to the weight of the water in the Eureka can, right? So just minus 8 minus 6, so you got 2 Newton. So actually, right, the weight of the water here, water displaced here is actually is 2 Newton. And this is called also as the buoyant force, right? Okay, so they want you to find the mass, right? So mean this one you have to change to mass. So 2 divided by 10, right? So the answer is A. Okay, so number 15, the answer is A. Alright, next one. Okay, so this is actually the Bernoulli Principle, right? So I already explained to you before. Okay, so this one, the both ends are closed. Okay, so means the velocity of the tube here is all the same. Okay, so means it's all the same, means the pressure is all same. Okay, so the answer number 16 is C. Okay, number 16, the answer is C. Alright, so next question. Okay, diagram 17 shows a tube with cross section. So which of the following is true about the situation? So this one is actually like a before like this also, the question is same like this. Okay, but for this one, the airflow is the air is flowing. So means there must have a velocity here. Okay, so here velocity is low, pressure is high. Okay, at S. Okay, so at T, the velocity is high, the pressure is low. Okay, so here when the pressure is high, so it will push the water to go down. Okay, so this one, this part will rise up. Okay, so the answer is which of the following is true about the situation? So pressure at S is less than T, so wrong, right? Pressure at S is higher than T, since here the velocity is lower. So pressure at pressure at T is actually same as the pressure at S plus H rho G. Okay, so this one is wrong. Okay. Alright, C, H is smaller in higher altitude. So H is equals to P rho G, right? So higher altitude, okay, higher altitude, H is smaller in higher altitude. So higher altitude means the pressure is lower, okay, and the H is lower. Wait, H is bigger. Wait, H is bigger when water is replaced with the cooking oil. So cooking oil is lower, the H is bigger. Higher altitude. Higher altitude means the pressure is lower, right? Because there's a low density. So the H is become smaller. And D, H is bigger when the water is replaced with cooking oil. So cooking oil is less dense than water. So H will increase. Wait. Okay, number 17. Can you leave up? I will see the question first, number 17. Because C and D, I think both is correct. Higher altitude, the density of oil, pressure is lower. Pressure is lower, H is also lower. Okay, so let's see for number 17, maybe up first. Okay, I will see first, then I will give you answer in the group later. Alright, we move to the next question. Okay, so number 12. Okay, so diagram 8 shows a man stand on one leg. So his weight is 720 meter and the surface area of the shoes is 0.02 meter square. So what is the pressure exerted by a man? So this one we use P is equals to F over A, right? So the force here is actually the weight 720, the area is 0.02. Okay, so you just divide number 12, the answer is D donkey. Alright, next one. So which diagram shows the correct direction of the pressure, the x on the liquid x, the x on the point x in the liquid. So this one the answer should be D. Okay, so the pressure will x in all direction. Okay, so number 13 is D. Okay, next one. So diagram 9 shows a simple barometer. Okay, so what happened to the height of the mercury H in the glass tube when the mercury is added to the container? So H will not change, right? Because here the H is actually measured the atmospheric pressure. So the atmospheric pressure is same, is constant. Okay, so if you put the mercury, you add some mercury, okay, the H will still be same. Okay, so the answer is B, boy. Okay, so H is usually 76 cm, right? Right, next one. So diagram 10 shows a water flowing into a venturi tube. Okay. So at which point is the velocity of water is highest? Okay, so this one we already know, right? Velocity low, pressure is high. Okay. So here velocity is high. So it's asking you to find the velocity of water is highest. So of course B. Okay. So number 15 the answer is B, boy. Okay, next one. Okay, diagram is 11 shows the identical block of the wood floating in the three different liquid X, Y, Z. So which statements about the upthrust is true? So the answer should be D donkey. 16 is D donkey. Okay, because the buoyant force is actually equals to the weight of the liquid displaced. Okay, so number 16, the answer is D donkey. Alright, number 19. So diagram 12 shows water spurts out from a vessel when the piston is pushed downward. Okay, so which of the physics principle explain the above situation? So the answer should be Pascal. Okay. Alright, next question. So diagram 13 shows the apparatus to measure water pressure. So what is the water pressure at X? Okay. So this one you can see the pressure here will push the water go down. This one the water will go up. Okay. So last week I think I already explained about this one. So if you want to find the water pressure at X, so you just plus with the atmospheric pressure. So 75 plus 3.8. So you got 78.8. So number 18, the answer is C. Okay. Alright, next question. So diagram 7 below show two type of wheel from two different cuts. So one cut has 4 narrow wheels and the other has 4 wide wheels. Okay, so in rainy weather, which cut sink less in the soft ground? So of course the wide wheels, right? Because the pressure is low, right? Number 12, the answer should be D donkey. Okay, number 12, the answer should be D donkey. Alright, for number 13, so diagram 8 shows U tube filled with liquid X and liquid Z, right? So the density of liquid X is 2.0 grams cm power of negative 3. So what is the density of liquid Z? So at this time we assume, right, both sides has the same pressure. Okay, so means you can use the formula H rho G is equals to H rho G. So means for X is equals to Z here. Px is equals to Pz. Okay, so the H for x, okay, so the H of x is 0.1, right? So 0.1 change to meter first because, sorry, no need because this one is already in cm, right? So also is cm, so no need. So 10 multiplied by 2, okay, times 10, okay. 2 is the density of x already given in the equation, and this one is 8, okay, 8 times, we want to find the density here, rho times 10, okay, right. So you got the answer is 2.5, okay, if not mistaken, 20 divided by 80, right. Wait. 20 times 10, 200, right? 200 divided by 80. Okay, so you got 2.5. So number 13, the answer is D donkey. Alright, next question. Okay, diagram 9 shows a syringe is used to suck a little water from a basin. Okay, so water in the bottle is forced into the cylinder of the syringe because the atmospheric pressure is, okay, so the answer should be C, more than the pressure inside the syringe. So it will push the water down, okay, and then the water can go inside the syringe here. Okay, so the answer is C. Right, next one. This one is a Bernoulli. Okay, so diagram 10 shows an aerofoil. So which part of the aerofoil has the highest pressure? So of course S. Okay, so this one because the velocity is lower, okay, the pressure is higher, so they will produce a lift force, right, and then we will go upward, right. Okay, so this one is also Bernoulli. Okay. Right, next one. So diagram 11 shows an apple is floating. Okay, so underline the word floating here. So if floating means the object is actually, okay, if floating means the object is actually, the weight is equals to buoyant force. Okay, so the statement should be, which of the following statement describe the buoyant force correctly? So the buoyant force equals to the weight of the apple. Okay, so the answer number 16 is B, boy. Right, next one. Okay, which of the following situation obeys Pascal's principle? So of course the answer is B. So when you push the toothpaste here, so the pressure here will go in all direction. Okay, so number 11 is B. Okay, this one using the Bunsen burner. Bunsen burner use the Bernoulli principle. This one is actually atmospheric pressure. This one is also atmospheric pressure. Okay. Alright, next one, diagram 12 shows an arrangement, okay, of an apparatus for an experiment. So which of the following conclusion is correct? Okay, so you can see all the water level is same, okay, even the shape is different, okay. So means the liquid pressure does not depends on the shape of the container. So usually they're influenced by the depth of the water, okay, the density of the liquid, and also the gravitational acceleration. So it's not depend on the shape here, okay, for pressure in liquid. Right, the next one, diagram 5 shows some fishes in aquarium. So which fish experiences the lowest pressure? So lowest pressure means, okay, same liquid, right? So mean the density is same. So the difference now is only the depth, okay? So the lowest pressure mean the depth is the lowest. So of course the answer should be A, okay? Alright, next one. This one is actually already answered, okay, before. Okay, so the answer should be pressure, okay? The first question, okay? This one should be pressure. Alright, the next question, which of the following devices use Pascal principle? So the answer should be hydraulic press. Okay, number 14, the answer is C. Okay, for this one, right? So diagram 7, it shows two barometer filled with liquid X and Y respectively. So the density of liquid is 12,000 kg meter cube. So what is the density of liquid 1? Okay, so you can see the barometer, usually they measure the atmospheric pressure. So my atmospheric pressure is same, right? So mean here the pressure is same as this one, okay? The pressure is same as this one, okay? So we can use the formula H rho G is equals to H rho G, right? H rho G is equals to H rho G. Okay, since the Px is equals to Py. So why Px is equals to Py? Because both of it is actually measured the atmospheric pressure, right? They just use the different liquid, right? But actually the value of the pressure is same. Okay. Alright, and then the H here already because this one is in meters, so this one have to change. So 0.8, okay. And then the density of X is 12,000, okay. And then also G is 10, okay, equals to, this one is 100 divided by 100 change to meter is 1. Okay, and then this one you have to find the rho here and the G is 10. Okay, so you just divide, you calculate using your calculator. So the answer should be B boy. Okay, I'll just give you the equation and you solve it on your own. Okay, alright, next one. Okay, so this one is actually using what principle? So this one is a Bernoulli, right? So the answer should be B boy, right? When you blow here, so this one blow in the middle of the ping pong ball here. So this one the velocity should be higher, pressure should be lower. So atmospheric pressure outside is higher, so we push the ping pong ball closest to each other. Okay. Alright, next one. Okay. So it says here diagram 9 shows a U tube which is filled with two immiscible liquid X and Y with different density. So the pressure at the both arm of tube is the same at the point Q and S. Okay, Q and S. Q and S. Because it's P, why not P and R? The P is actually it depends on the atmospheric pressure only. Okay, so Q and S. So this one is actually for atmospheric pressure only, but this one atmospheric pressure plus the plus the pressure of the liquid. Okay, so that's why the answer should be Q and S. Alright, for number 13, okay, diagram 11, okay, shows a siphon to remove dirty water from aquarium which is placed on the cupboard. Okay, so which statement does not explain this situation? Okay, pressure at P same as the pressure at Q, yes. Okay, should be same here. Okay, and then the siphon cannot function if there is a leak between P and Q, yes. Because if the leak here means the atmospheric pressure will be acting on the rubber tube here. Okay, so it's not, it cannot function. Okay, and then this for C, the pressure in the rubber tube at R must be equals, okay, to the pressure at P, okay, to ensure the continuous flowing of the water. Okay, so this one is the answer. Okay, pressure in the water R must be equal to the pressure at P, ensure the continuous of the flowing of water. Okay, so number 13, the answer is C. Alright, next one. Right, number 35. So diagram 12.1 shows a Cartesian diver with a few holes in it. The diver is placed in a flexible bottle of water. So diagram 12.2 shows when the bottle is squeezed, the diver sinks, and when the bottle is released, the diver rises. So the Cartesian diver will work based on the Archimedes principle. Okay, floating and also the floating usually they use the Archimedes principle here. So number 14 is D donkey. Alright, for number 16, diagram 14 shows the umbrella being flipped up by a strong wind. So which statement is correct? Okay, so the answer, the speed of air the speed of air is lower below the umbrella. Okay, so the answer is A. Okay, and the speed of air lower, okay, above the umbrella. Okay, so the pressure there will be, wait. No. Speed of air lower above the umbrella means the velocity, the pressure is high, right? So number for B, more air is trapped below the umbrella. So wrong. Pressure above the umbrella is lower than under the umbrella. So the answer should be C. Okay. Pressure above the umbrella is lower than under the umbrella. So that's why the umbrella move upward like this. Okay. So number 16, the answer is C. Okay. Right. Next one. So diagram 14 shows a car has a weight of 18,000 Newton. So the surface area of each car tire is in contact with the ground is 16 cm, okay, square. So what is the pressure exerted on the ground by each tire? Okay, by each tire. So means you have to divide using the formula P is equals to F over A. Okay, so because it's asking you about each tire, so 18,000. Okay, alright. So because they use the unit Pascal here, right? So need to change to meter. So how to change to cm square to meter square? Okay, so 16 cm square. Okay, so centi is 10 power of negative 2, right? So 10 power of negative 2. Okay, so since this one is square, right? So this one also you must square the prefix. So 16 times 10 power of negative 4. Okay, so because it's asking you by each tire, so mean only one, right? So we just divide 16 times 10 power of negative 4. Okay. Um, 80,000, 16 negative 4. So the answer should be, there's no answer here. Unless if you said that 1.12 times 10 power. Wait. I got 1.1 times 10 power of 7, right? But there's no answer here. Okay. So the answer should be 1.1 times 10 power of 7. Okay. No answer here. Okay. The answer should be 1.1 times 10 power of 7. Right. Okay. Let's move to another question. Okay, diagram 15. Okay, diagram 15 shows an inflated balloon that is connected to a manometer. So what happened to the height h of the mercury in the manometer if the balloon is pressed? So if the balloon is pressed here, the pressure will become higher. So it will push, the water goes down, and this one should be rise up. So the h will be increased. Okay, so number 15, the answer is A. Alright, next one, number 16. So diagram 16 shows a suction pump which is pressed, okay, which is pressed against wall. So the pressure at X is, okay, so lower than atmospheric pressure. So it will become partial vacuum here. Okay, so means the pressure here is must be lower than the atmospheric pressure. Okay, number 16, the answer is D donkey. Okay, number 17. Okay, diagram 17 shows a model of simple hydraulic system. So the weight of the load is 500 Newton. The ratio between the cross-section area of piston X and Y is 5 to 1. Okay, 5 to 1. Okay, the weight of the load is 500 Newton. So the question asks, what is the force F exerted on the piston Y in order to support the load? So this one use the Pascal, F1 equals to divide by A1, F2 divide by A2. Okay, so 500 divide by 5, F2 divide by 1. Okay, so we just multiply, okay, cross multiply. Okay, so the answer should be A here, right? Alright, the next one. Okay, diagram 18 shows a log of 5 kg floating freely on a sea water. So floating. So floating means this one is Archimedes. So the weight of the log here is equals to the buoyant force, right? So the question one you to find the buoyant force. So you just need to find the weight of the log here. So 5 times 10. So the answer is 50. Okay, so the answer 18 is C. Okay, for this one, diagram 19 shows a student blowing above a thin sheet of paper. Okay, so the paper rises upward because, okay, so this one using the Bernoulli. Okay, so the atmospheric pressure below the paper is higher than the air pressure above the paper, right? So when you blow, okay, when you blow here, this part will be velocity higher. This one should be pressure lower. So here atmospheric pressure is higher. It will push the water paper going upward. Okay, number 19, the answer is A. Alright, next one. So diagram 8 shows the hydraulic system. So this one is actually Pascal. Okay, so A, the physics concept involved is Bernoulli, wrong. This one should be Pascal. Piston Y has a higher pressure than piston X. So wrong. This one is a Pascal. So Pascal said the pressure must be same, right? So the force exerted on the piston X is equal to the force pressure and exerted on piston Y. So this one is wrong. This one, the force is actually depends on the cross-sectional area, right? So P is equals to F over A, right? So PA is equals to F. So if the area is bigger, right? So the F also increase. Okay, so means the force here much bigger than X. So Fy is bigger than Fx. So the force, so C is wrong also. Okay, and then the next one, for D, the force on piston Y is 200 Newton. Okay, if the surface area of piston Y is 2 times bigger than surface area of piston X. So this one is correct. So let's say this one is twice bigger than the area of this one. So of course the force will be 2 times bigger also here produced at Y. Okay, so the answer should be D donkey. Right? Okay, next one, diagram 9 shows a water, okay, and then the base of the ball is thicker because, okay, why this part is bigger? Because the pressure of the water is highest at the base because the depth is, okay, higher compared here, right? So the answer should be C. Okay, number 14 is C. Okay, for this part, diagram 10 shows an elephant of 5,000 kg mass on a wooden platform with an area of 50 cm square during a circus performance. Okay, so what is the pressure applied on the platform? So this one use the P is equals to F over A. So the force must be in Newton. So the mass is 5,000. So mean the force is 50,000. Okay, and then also the area. So you see the area here is cm square. This one is meter. So mean you have to change. So I already teach you how to change from cm square to meter square. So centi is -2, right? So this one also you must square it because cm square. So let's say 50 cm cube. So this one should be power of 3. let's say, but this one is power of 2, so you just power of 2 here. So 50 times 10 power of negative 4. Okay, so you just divide. Okay, so you got the answer is D donkey. Okay, D donkey. Right, next question. Okay, diagram 11 shows a manometer which is connected to a gas supply. So the difference in height H will increase when. Okay, so use the formula H is equals to P divided by rho G. So if you want to increase the height here, okay, the density should be lower. Okay, so you must use the liquid that have a lower density. So the answer should be C. Okay, so the answer should be C. Alright, next question. Alright, so what is the pressure of gas Y if the atmospheric pressure is at 76 cmHg? So this one, the gas is higher than atmospheric pressure, right? So you just have to add the atmospheric pressure with the difference of the length here, okay? So this one, the difference of the length is 20 minus 10, okay? So the answer is 10 cm. So plus with the atmospheric pressure, 76. So you got the answer is 86. So 76 plus 10 is 86. So 17, the answer is B, boy. Okay, number 17 is B, boy. Alright, the next one, which of the following instrument is used to measure the atmospheric pressure? So the answer is A barometer. Okay, manometer is pressure of gas, measure pressure of gas. Hygrometer is actually for the density, okay, the density of the liquid. And galvanometer is actually to measure the to measure the induced current, right? Okay, number 19, diagram 13 shows a boy lie on a float. Okay, so which relationship between the physical quantities in the above situation is correct? So again, okay, it's float, right? It's float. So means the weight of the liquid atau water displaced is equals to weight of the body plus weight of the float. Okay, so number 19, the answer should be A. Alright, for number 20, actually this one is a Bernoulli, right? So the pressure, this part, right, the speed of water is higher, so the pressure is lower. And this part, the atmospheric pressure is higher, so it push the ping pong ball upwards, so the ping pong ball will not fall down. So the answer is B, ball. Okay, for number 19, okay, which of the following shows the height of H of simple mercury barometer that measure the atmospheric pressure? So it must from the surface of the mercury here until here only. Okay, so from here until here only. So the answer number 19 is B, boy. Okay. Alright, number 18, diagram 13 shows a cylinder contains air. Okay, so when the piston is pulled upward, which of the following is true? Okay, the density of the gas molecule increases. Okay, and B, the distance between molecule of gas is increases. So of course the answer is B. Okay, the distance between the molecule of gas increases. Okay, number 18, the answer is B, boy. Alright, next one, diagram 8 shows a plastic bag filled with the air attached to a manometer. So a load is then placed on the plastic bag. So you put the load here, okay, on the top of the plastic bag. So what happened to X? So this one means the pressure is increased, right? Okay, so when the pressure increase, so we push the water here, mercury here, go downward, and this one will go up. So the answer should be 17 is A. Right, number 54, next question. Alright, diagram 11 shows a Bernoulli tube. So based on the Bernoulli principle, which tube has the lowest water level? Okay, so I already explained before. Okay, so this one, the velocity low, pressure is high, right? So pressure high here, so it will push the water, okay, from going up. So this one should be lowest. And here velocity is velocity is high here, pressure is lower. I'm sorry. Wait. I'll explain again. Okay. So this one velocity is high, pressure is lower, right? So when the pressure is lower here, the water can rise up, okay, because the pressure low, so it will not push the water from going up. So this one should be right. At this point, the velocity is lower, pressure is very high, okay. So pressure high, it will push the water from going up, okay. So the water is very less here, okay. Okay, so the answer should be B. Okay, number 20, the answer should be B. Okay. Velocity high, pressure is low. So water can rise up. Right, this one, the velocity low, pressure is high. So it will push the, okay, so the answer is B here. Alright, next question. Okay, diagram 9 shows a manometer is connected to a gas supply, right? So the difference in high H will increase if, okay, so this one we already answer, H is equals to P over rho G, right? Okay, so if you want to increase the H, you have to use the liquid with smaller density, or you put the manometer at the lower pressure, lower atmospheric pressure. Okay, so the answer should be C. Right, next one. Okay, the actual weight of an object is 12 Newton. Okay, so the apparent weight of the object when it's immersed in water is 9 Newton. So what is the density of an object? Okay, okay, so here you have to find the buoyant force first, right? So you know the buoyant force is actually 12 minus 9. Okay, so the buoyant force is 3. Okay, so 3 is equals to rho Vg. Okay, and then you find the density is already given here, right? 1000. Okay, find V here. Okay, and G is 10. Okay, and then you got 3 times 10 power of negative 4. So this is actually the volume of the object. Okay, and then okay, you use the formula density. Density is mass divided by volume, right? Okay, so you want to find the density of an object, you use this formula. Okay, mass. How do you want to find the mass? You already know the weight is actually 12 Newton, right? So if you want to change from weight to mass, you just divide by 10. So you got 0.12 here. Okay, 0.12 here. And then the volume already calculate before. So 3 times 10 power of negative 4. Okay, and then you just use the calculator. So you got the answer is D donkey. Okay, find the volume first. Okay, so this one is actually we assume that the object is totally immersed in the water. Okay, so means the volume of the liquid is the volume of the object is actually equals to the volume here. Okay, V here. Okay, 3 is equals to rho Vg. Okay, 3 is 1000 times P times 10. Okay, so you got the V is 3 times 10 power of negative 4. So we just assume, so let's say the water here, so the object is totally immersed here. Okay, so means the volume of the object we can find by using this formula, by using the buoyant force formula. Okay, so you got the answer D, donkey. Alright, the next one. Okay, last one, okay. Alright, so this one is actually Pascal. Okay, Pascal. So this one use F1 equals over A1 is equals to F2 over A2. Okay, F1 over A1 is equals to F2 over A2. Right. Don't forget this formula. So 80 divided by 0.03, okay, equals to F2 you want to find. Okay, and then divide by 0.9. Okay, and then you just cross multiply. Okay, so the F2 you will get the answer B, boy. Okay, 2.4 times 10 power of 2. Okay, but you have to remember the one that you find is actually the in Newton, right? Okay, and then you have to change, okay, divide by 10. Okay, after you got the value of F2, you have to divide by 10 first. Okay, because this one, they want the mass. Okay, this one is actually the weight. Okay, so divide by 10 first, so you got the answer. So number 44, the answer should be B, boy. Okay, so I guess I stop first. Okay, until that. Wait, I take your attendance first. Okay. Okay, thank you class. So I see you on tomorrow.